At this point, you should have set up your Vagrant box. You should have set up AWS. So now we can launch our Kubernetes cluster using kops. Here I'm logged in to my Ubuntu Xenial box. Before setting up the cluster, you need to make sure that you have kubectl installed as well. This URL you can find in the procedure document. You can just download it. You move it to user local bin, exactly where kops is as well, and you give it execution permissions. And then when you type kubectl, you have kubectl available. Before creating the cluster, you will also have to create new SSH keys, and those SSH keys will be used to log in to the cluster. SSH keygen can create new keys. So what I'm going to do is I'm going to create a new key in .ssh id RSA. And this public key, id RSA pub, will be uploaded to our instances. And that way we will be able to log in to our instances using our private key. So id RSA is our private key. This is our public key. Public key goes on the instance and we log in with the private key. And just one thing I want to do before I'm going to enter the kops command is I'm just going to rename the kops binary. I'm going to rename it in just kops rather than having kops Linux AMD64. This is the kops command I'm going to execute. And this kops command is not going to do anything yet because it needs another step before it's really going to execute the commands on AWS. But this one is going to create one master, a T2 micro, and two nodes, also T2 micro. So we have kops create cluster, we give it a name. This needs to be the full DNS name of the cluster. I have Kubernetes New Tech Academy, the one that I set up in Route 53. I'm going to save the state in S3. This is my S3 bucket. And I'm going to launch it in the EU West 1A zone. You're probably going to use another zone. US East 1A, US West 1A, and so on. Node count is 2 and the node size is T2 micro. The master size is also T2 micro and the DNS zone is Kubernetes New Tech Academy. I'm going to execute this and then you will be able to preview the changes that will be made to AWS. So it's going to make auto-scaling groups for our nodes. It's going to launch a master. It's going to provision also SSD drives. And then if we want to really launch this cluster, then we can just do this with kops update cluster and then the name with --yes. And then it's going to launch. If you want to make changes first, you can edit the cluster using kops edit cluster and then the name. But because the state is on S3, you also have to specify the state. So then the command will work and then you can still make some changes. I'm not going to make any changes at this point. I'm just going to launch the cluster. So I'm going to do kops update cluster and I'm going to specify yes. And again, I will specify the state. This will then launch the cluster. It will take a couple of minutes and then I can try to run one of the examples. So now the cluster has been created and let's have a look what this means. Road config for Kubernetes New Tech Academy in this file. I'm just going to get this file. And this is actually the certificates that we need and the password to log in to our new cluster. That's what kops configured already for us. So for instance, we have here the server HTTPS API Kubernetes New Tech Academy, and that's what we will be able to use. Let's see if the nodes are up. So kubectl get node. 3 nodes in ready status, 1 master. This is going to be the master. It's in a different IP range. And then 2 nodes. Let's try to run the same deployment as we did on the Minikube cluster to test whether our Kubernetes cluster using kops is working. So I'm going to do kubectl run hello minikube, which is the name of the deployment. And it's going to use this image, the Echo server version 1.4. And Echo server in this Docker container listens on port 8080. So we specify port 8080 as an argument. This is going to create the deployment hello minikube. And now we can also expose this service so that we can access it externally. We can do that using kubectl expose deployment, the name of the deployment, which is hello minikube, and we give it a type. This is the type of the service. For example, if you want a load balancer in front of this service, then we can say type load balancer, which I will cover in the next lecture. I'll do now a more simple version, just node port, which will expose a port on every node of this Kubernetes cluster that we can contact this service on. It is on every node except the master. So you can connect to every node on a specific port, but not on the master. So service hello minikube exposed. So if you now do kubectl get services, we see now our hello minikube service type node port, and this is the port that we can contact our service on. So this port is now open on every single node in our Kubernetes cluster except the master. Let's have a look at the AWS console. Let's first go to EC2. Make sure that you are in the correct region. I launched it in Ireland, so I'm in the Ireland region. And then you should see 3 running instances. So I have here 2 nodes and 1 master node. This one is terminated, so you can ignore this one. If you don't see your nodes, you can also have a look at the autoscaling group, which is here on the left. Autoscaling groups. You should have 2 autoscaling groups, one for the master and one for the nodes. And it's this autoscaling group that will launch the instances. So if something is wrong, for example, if you're reaching AWS limits, then it should be displayed here. Then for some reason, it couldn't launch an instance. But for us, everything went fine. We have 2 instances running. We exposed the node port, which means that those 2 nodes will reply on this port and redirect my traffic to this service. Before we can access it, we need to make sure that the firewall is not blocking us. So these nodes have also a firewall. They have a security group. And to see the security group, you just can click on the instance and then you can see the inbound and the outbound rules. So here port 22 is open, but not the node port that we just created using this service. So we will need to make changes to this. So if I click on the security group, I go to inbound, I click edit, I can add a new rule. I can say custom TCP. I can copy paste the port that is exposed. So this was 30,032. I can paste this here and you can either open it for everyone 0000/0 or only for my IP address. I'm going to choose only my IP address, so only me will be able to access this service. I click save. I can go back to my node and I can take the external IP address of this node or of this node. The IPv4 public IP address is listed here. I can copy this. And if I go to this IP address, port 30,032, I get the response from my service that I launched on my Kubernetes cluster. So this works. I have a running Kubernetes cluster. I have 2 normal nodes and 1 master node. And I created our first deployment, our first service, and I exposed a node port that I now can connect to using the IP addresses of any of those 2 nodes. In the next lecture, I will explain you a better approach using a load balancer that gives you also a host name, and then you can also use DNS to give your service a real DNS name, a real domain name. So once you did this demo and you are not using the cluster anymore, I would recommend you to remove the cluster. So I will show you how to do that. So to delete our cluster, we can do kops delete cluster, then the name of the cluster, Kubernetes New Tech Academy, in my case, and then we can also add the state. So the state is in S3, and then it's going to show us what will be removed. We must specify yes to delete the cluster. So we're going to execute the same command using yes, and that will then bring the cluster down again. And the next time you want to use it again, you can just execute kops create again, just like you did in the beginning of this lecture. So if you have any issues with bringing up this cluster, there's a troubleshooting lecture if you have DNS issues, or you can use a Q&A to ask me questions if you run into any problems. If everything went fine, just continue with the next lectures. This deleting of the cluster will take a couple of minutes, and then the cluster is removed.